Welcome back to Think Thrice Problem Solving. Today we're going to be solving a really fun little geometry problem. So in this problem, it looks kind of like it might be easy, but it ends up being a little trickier than initially looks. So if you want to give it a try, go ahead and pause the video and give it a shot. Otherwise, we're going to jump straight into a solution. So what we're going to look at here is we're going to look at some radii real quick. So I'm going to go ahead and draw the center of my circles. So these circles all have the same radius. The radius is 2. And if I look at the radius, so I notice something interesting. The radius goes from one center to the other. My radius is also going to go from the center to here and the center down to here. So what does that tell me? That tells me that all 3 of these sides are exactly the same length, which in turn means that these 3 angles are the same angle. So it's an equilateral triangle. And in an equilateral triangle, all of my angles are going to be 60 degrees or pi over 3 radians. All right, so that's kind of the interesting thing that we're definitely going to need, and that's going to start us toward our solution. So overall, what I want to note is that when I look at this circle, if I want to calculate the area of the green, so I'm going to call that A sub g, that area of the green is going to be the area of a whole circle minus 4 times the area of this shape, which I'm just going to kind of draw here. So I have this equilateral triangle, and then I have these little curves coming around the outside. So we're going to subtract 4 times that shape, and by symmetry, that's going to then give us the area of our whole figure. So really the question becomes, what on earth is the area of this little figure here? Because my area of my circle is easy to calculate. If we want to get the area of the circle, so A sub circle is just going to be pi times my radius squared, which is going to be pi times 2 squared, which is just going to give me 4 pi. So my area of my whole circle is just going to be 4 pi. So this guy checked off. So really to get that area of that green section, I just need to do a little bit of math to figure out that guy. So what I notice here is this shape, which I'll draw down here. So this shape, no, it's not equilateral, I apologize, is the sum of my equilateral triangle plus 2 times whatever this little guy is on the side. So I'm going to add 2 of those little guys, and that's going to give me the area of that shape. So starting off with my equilateral triangle, that's pretty straightforward. So let's go ahead and draw this equilateral triangle. I know all of these sides are 2. So if I was to draw a perpendicular down, then this perpendicular of this little triangle is going to be 1, and I can solve for my h. So I know h squared plus 1 squared is going to equal 2 squared by the Pythagorean theorem, which tells me that h squared is equal to 4 minus 1, which is 3, and that h is the square root of 3. Why is that useful? Because the area of this triangle is going to be equal to 1/2 the base times the height, which is going to be 1/2 my base, which is 2. The whole base down here is 2. This 1 is just the little side over there, times my height, which is square root of 3, which tells me that the area of my triangle is the square root of 3. So we're well on our way here. We're looking pretty good. And as kind of we expected, this last section may be problematic. So the question is, how do we find the area of this little crescent, not really a crescent, but this little region up here to the right of our equilateral triangle? And that's really the nuts and bolts of it. So what we're going to do is let's look at this whole circle. And we're going to use a little bit of a trick here. So I'm going to go ahead and break this into my pizza slices. And we notice that if I break it up like this, each of these guys is 60 degrees because I have 360 in my whole circle. So if I have 6 slices of my pizza, all of these guys are going to be 60 degrees. Okay, so that means that each individual pizza slice, so one pizza slice, is going to be 1/6 of my area of my whole circle, which I already know, so 1/6 of 4 pi, which is going to be 2 pi over 3. And then this pizza slice, what do I notice about the pizza slice? The pizza slice is a triangle plus my little piece over here. So now I can just do a little bit of math to figure out that this red piece is then going to be equal to that 2 pi over 3 that I just calculated minus my area of my triangle, which was the square root of 3. So what have I got here? So now I have the area of this little piece here. I have the area of my triangle, which means that I now have the area of this whole region, so I can calculate my overall up here. So let's go ahead and look at that. So the area of my region right here is going to be equal to my area of my triangle, which is the square root of 3, plus 2 times 2 pi over 3 minus square root of 3. So that's going to be square root of 3 plus plus 4 pi over 3 minus 2 square root of 3, which is then just going to give me 4 pi over 3 minus the square root of 3. So now I have the area of this funny shape, and now I'm ready to just plug it into my equation all the way up here. So the area of my green region is going to be the area of my whole circle minus 4 times the area of this shape here. So my area of my green is going to be equal to 4 pi, because that's what I calculated as my area of my circle way up here. Oh, sorry. Minus 4 times 4 pi over 3 minus square root of 3. So that's going to be 4 pi minus 16 pi over 3 plus 4 square root of 3. I have to distribute those negatives. And then remember that 4 pi is 12 pi over 3, so this is going to end up being 4 square root of 3 minus 4 pi over 3, because 16 pi over 3 minus 12 pi over 3 is 4 pi over 3. And that is going to give me the area of my green region. It's going to be 4 square root of 3 minus 4 pi over 3. So I hope you enjoyed working through this little problem. It was pretty fun. We got to deal with a bunch of little shapes in a bunch of different areas using a few different methods to get to our solution. If you enjoyed this video, please like and subscribe. If you have an idea for another video, please submit it to thinkthriceproblemsolving@gmail.com. And as you're working through problems on your own, think once, think twice, and if you ever get stuck, think thrice.